Hello, my name is Yurii Turbal. I am professor of the National University of Water and Environmental Engineering here in Ukraine. Our topic is modification of the permanent decomposition method for the meeting scheduler problem. The task of calendar planning have not lost their relevance in recent years, despite the presence of a large number of theoretical results and practical approaches to their solution. Scheduling problems is the most widely studied problems in computer science. There are well-known job shop scheduling or the job shop problem, the node operation research problem of finding an optimal way to assign nodes to shifts. We will consider only the most popular problem areas for the use of planning tasks. In the last publication, we consider meeting scheduler problem and propose an algorithm for the meeting scheduler construction, which is based on the procedure of incidence matrix decomposition. At the head of this approach are procedure of the permanent decomposition of incidence matrix with memorization of identifier elements. This approach was called PD method. And the result of PD procedure was creation of the system of different representatives of the list of sets. In this paper, we present a new modification of the PD algorithm, which includes modification of the incidence matrix construction and procedure of the permanent decomposition. The new modification allows to build all possible variants of schedulers according to the system of different representatives. For effective software implementation of the proposed modification, the use of special additive disjunctive forms is proposed. What is the objective of our research? Let's consider end product teams C1, C2, so on, Cn, and Scrum Masters P1, P2, so on, PM. It is needed to hold a certain number of meetings during the working week with individual project teams of or groups of teams at the same time. It is necessary to form a scheduler for meetings of managers with work teams during the week. Obviously, the schedule can be represented in the form of a matrix. You can see such matrix on the formula 1, where C1, C2, C3 is Scrum Masters, T1, T2, so on, is times of a meeting. We have a lot of problems during this scheduler construction. It is obvious that the manager of Scrum Master can hold only one meeting at a time. If we assume that one person cannot meet with several teams at the same time, then the presence of two identical elements in the row of such matrix determines its inadmissibility. If it is possible to meet certain commands at the same time, then the presence of the same elements in the line may be allowed. Thus, there is a problem of finding a valid configuration of the meeting scheduler matrix. On the slide, you can see modification of incidence matrix. In Formula 2 and Formula 3, we consider such matrix in our previous publication, and note that incidence matrix 2 doesn't provide comprehensive information for scheduling. Therefore, in this paper, we consider modification of the incidence matrix where Nij is the number of occurrences of the element Aj in the set SCSA. You can see a small example for the matrix scheduler matrix R. You can build such matrix of incidence, and you can find elements 2 in the set row. To calculate the modified permanence of the incidence matrix, we can use an analog of the known algorithm for the decomposition of the determinant by a line. You can see a small example, formula number 4. It's example of the permanent decomposition method. Results of this decomposition, you can find a system of difference representatives as height indexes in our decomposition in our results. One with index n is stream or flow elements. We consider two kind of elements, normal elements and stream or flow elements. If we analyze the process of permanent decomposition, we can see that operation of adding can be used in special sense. If we consider process of permanent decomposition, we can use adding operation as mandatory inclusion of both components or choice of one of two options. For example, in this expression, we have index of element 3 equal 2, and we use addition as mandatory inclusion of both components. And in another expression, when index equal to 1, adding means choice of one of two options, because element 3 must be included in the system of difference represents only once. So we can define an expression containing elements using the specified operation as additive disjunctive forms, ADF. You can see small property of ADF on this slide, and now we can modify the process of permanent decomposition and use the ADF. We propose such algorithm of generation all correct variants of scheduler using ADF. This algorithm consists of several steps. First step is formation of the initial general blocks. Second steps, second and third and next steps is analysis of all lines of the incidence matrix. And if we consider, for example, second row of incidence matrix, we must for each non-zero element determine in which CDR list it is present. Then we determine all possible options so that it is included depending on its index. And to do this, number of CDR, where the second element is our running element, consider all possible combinations with CDRs containing our second elements, and the number of which is equal to its index, and check the required number of its occurrences. Its main idea of this analysis of every row of incidence matrix. And on another slide, you can see an example of our algorithm, of using our algorithm. In input data, we can consider a system of difference representatives for incidence matrix file and analyze every row of the matrix file, and from the system of CDR, which input system, we construct ADF, additive disjunctive forms. So you can use now additional operation for the mandatory inclusion and disjunctive operation if you have choice one or another element. So results of our algorithm on the last step, you can find correct scheduler. On the next slide, you can see our elements of our program realization. We consider class CDR, class incident, class ADF. We construct a system of special classes and create a number of special functions for our program realization, such as start getter for it generates the initial ADP, ident, which analyze CDI and check stream correctness, generate legs, good blocks, copy blocks, generate new blocks, and so on. number of functions. And on the next slide you have a small example of the program realization. We construct correct scheduler for the element 1, 65, 2, 3, and 4. We have 4 numbers of our Scrum Masters and build correct scheduler according to the matrix of incidents. Thus, the paper considers a modification of the PD algorithm for generating system of difference representatives, which allows to immediately obtain all possible admissible schedulers. Our modification is based on the use of special forms, which we called additive disjunctive forms. Such forms can be useful for a wide range of tasks of generating combinatorial object scheduling. Clear algorithms are proposed for constructing meeting scheduler based on ADF, one of which uses a system of difference representatives as input data, which is built on the basis of PD algorithm. Our approach easily fits into the object-oriented programming paradigm and can be implemented using any object-oriented programming language. Thank you for attention.